gonna do another problem. This problem is gonna be 2 2/3 multiplied by 12. The very first thing we have to do when we see a problem with fractions is we need to observe it. So what do we observe about this problem? We're looking at the operation. It is multiplication. We're looking at this is a mixed number, that is a whole number. We're looking at, oh, the denominator, because if we didn't have a 2 here, could we model this problem? Yes, so we're going to keep all of this stuff in mind. But first we're going to just solve it with the procedure, since that's what we just did up here. So we are going to, if we notice that the denominator goes into our whole number evenly, what does that mean for our answer? Is our answer going to be a mixed number, or is it going to be a whole number? I guess we'll see. So we are going to do the procedure. We're going to go the whole number from the mixed number, which is 2, times the whole number, which is 12, and we're going to add the fraction from the mixed number, which is 2/3, multiplied by the whole number, which is still 12, and solve this. Okay, what is 2 times 12? It is 24. What is 2/3 times 12? Well, because we're not modeling this, we have to go 2 times 12 is 24. So this would be 24 thirds, because we multiply the whole number times the numerator, place it all over the denominator. Will this 3 go into 24? It does, evenly. 3 times what? 8. So we converted this to a whole number. Now we add 24 plus 8. What is 24 plus 8? 8 equals 32. So 2 2/3 times 12 equals 32. Our answer is what kind of number? A whole number. And the reason why it's a whole number is because our denominator goes into this whole number, not the number that not the whole number it's attached to, but to the whole number it's multiplying by evenly. Well, just like if this was just 2/3 times 12, we can model it. We can also model this problem as well. So modeling. We can only model if the denominator can go into the whole number evenly, just like if it was fraction times a whole number. So we can only model if the denominator can go into the whole number evenly. In this case, it can. So now I want us to think, how is this going to be different than when we multiply a fraction by a whole number? I want, take a moment and think about that. How is our model going to be different? And we're going to think about this. And we talked about this earlier in the year, and I've been racking my mind all day, and I cannot remember what we talked about, but we talked about how earlier in the year we talked about how we have to have like an extra piece for something, and I don't remember what it was, but we had to have so many pieces and then an extra piece to show, and it might have been numbers in base 10, how we had to have another part for the decimal pieces. So I want us to think about that I'm sure you guys remember because you guys have a younger brain than me. But I can't remember what concept we were talking about, but we were talking about how we had to have as many holes as there was and then an extra piece for our parts. And that's the same sort of thing when we're multiplying a mixed number by a whole number and we can model it. We have to have enough holes for how many holes there is going to be, and we have to have one more for the part. So something that we have to keep in mind is that we are going to split our model into the mixed number the whole number, the mixed number, the whole number from the mixed number plus 1. So we're going to split our model into 2 plus 1. What's 2 plus 1? 3. And the reason why we do this is because we need pieces for the holes plus 1 for the parts. So we need enough pieces for the holes that we're going to have, and we need one more piece for the parts. So we're going to have 2 holes, and then we're going to have parts of a hole. So we need 3 pieces in our model. Unlike when we model with fractions times a whole number, this fraction bar doesn't equal 12. Okay? Each piece of our fraction bar is going to equal 12. So each piece is going to represent one whole. We are going to split this into 3 pieces. And each one of these pieces is going to represent 12. It's going to be one whole. So we're going to have 12, we're going to have 2 holes and a part of a hole. So we're going to have 2 holes, which means how much is our hole worth? 12. And then we're going to have part of a hole. Well, in this portion right here, this problem is going to look like, is going to be our 2/3 times 12. This is going to be our 1 times 12, 1 times 12, which is 2 times 12. So this is going to be our 2/3 times 12. Well, what do we need to do? We have to split this now because this part is a whole. Just like when we have fraction by whole number, we have to split this into our denominator. And our denominator is how much? This is our groups. That's going to be 3. We have to do our baby problem and we have to think. 3 times what equals 12? Hopefully we're all saying 4. That means that 4 is going to go into each part. So now we have to model that we are taking these pieces, or we have these pieces. We're going to go 1 whole, 2, and we're going to take how many of this part? We're going to take 2 of the 3 pieces. So now we have 12 plus 12 is 24, and then we have 4 plus 4 is 8. 8 plus 24 equals 32. So here, I didn't have to do any converting. I got the same exact answer. I just modeled it. So I was just adding. So this would be the 2 times 12, which is this piece right here. And then this is going to be the 2/3 times 12. And then you just add up what you take.